Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In the previous video, we saw what is stress, that is resistance to the deformation per unit cross-sectional area, then strain, that is deformation per unit original length, and their units also. Now in this video, we will see some important properties of the material, because whenever any machine part or any member of a structure is subjected to external load, the behavior of that particular member or machine part depends upon various properties of material of that particular member. Okay, so let us see some important properties today, that is ductility, elasticity, plasticity and elastic limit. Now let us see what do we mean by ductility. It is the property of a material by virtue of which it can be drawn into smaller cross sections without causing failure. This is known as ductility. Ductility is the biggest property, most important property of mild steel, due to which the mild steel bars are used as reinforcement. As far as steel structures are concerned, mild steel structural elements are used, okay, because as they are ductile in nature, even if that particular structure is overloaded, it gives some deformations, due to which we get the prior intimation of the impending failure. Now once again I will repeat, ductility is the property of the material by virtue of which it can be drawn into smaller cross sections without causing failure. Now this ductility can be measured with the help of percentage elongation. Some materials are having higher ductility, and for those materials you can draw those metals into thin wires. In short, whatever wires are available in market, all those are ductile. Means you can get mild steel wire, you can get copper wire, you can get aluminium wire, you can get silver wire, you can get gold wire, you can get platinum wire. So all these materials are having higher ductility. Mild steel, aluminium, copper, silver, gold, platinum, etc. all these are ductile materials. Okay. Now the materials which are not ductile, that means cannot be drawn into smaller areas, are known as brittle materials. Okay. Cast iron is brittle material. Okay. So do you understand ductility? Ductility is very important property. Due to this ductile nature of mild steel, various operations can be done on it. Its machinability, ability to get machined is also more. So ductility, from civil engineering point of view, it can be used as reinforcing bars, okay, because due to bending it can bend, okay, so it can resist the stresses, and in case of overloading, in case of earthquake also, ductile nature of reinforcement or mild steel helps the structure to become, you can say, earthquake resistance. Okay, so earthquake resistance is one of the important properties. So this is regarding ductility. Now let us go for the next, that is elasticity. We know elastic material. It is the property due to which it can deform when load is applied, and the deformation vanishes completely after removal of the load. This is known as elasticity. The property of a material due to which it can deform, or it deforms due to application of load, and deformation completely vanishes on removal of the load. This is known as elasticity. Means whatever deformation is there in these bodies, that deformation is temporary. It will vanish as long as, it will be there as long as loads are applied. It will vanish as soon as load is removed. Now let us see plasticity. It is the property of material due to which it deforms due to application of the load, and when the loads are removed, the deformation will not completely vanish. There will be some deformation remaining in that. That means whenever a particular material is loaded beyond a certain limit, then it can have this property of plasticity, that is, some permanent deformation will be there. That means the material will enter into plastic state. It's very important, plasticity, because some mechanical operations such as forming and shaping of the, you can say, material can be done in this particular plasticity state. Okay? Now, ductility, elasticity, plasticity. Now, ductility is very important, elasticity is also important. Plasticity will take place when the load will exceed a particular value. Now, let us see what do we mean by elastic limit. Now, for a particular material, there is always one limiting value of load beyond which, if the load will be exceeding, or beyond which if the load is increased, the material will not behave as elastic material. Means what is elastic limit? It is the value of load up to and within which the material will perfectly behave as an elastic material. The stress corresponding to this particular point is known as elastic limit. Now, it is important to note the elastic limit, because we have to go further for Hooke's law. Now, you will have a doubt in your mind, what will happen if the load exceeds this particular limit? Now, here we already saw that whatever deformations will be produced if load exceeds this limit, those deformations will be permanent, and that is known as permanent set. So what is that? If body of elastic material is loaded beyond elastic limit, the deformation produced will remain in the material as a residue, and such a residual strain is known as permanent set. So this is very important. You can write these definitions. I have told you the importance of ductility, elasticity, plasticity. Okay. Now let us go further to go for an important one, that is Hooke's law. H-O-O-K-E. Now what is Hooke's law? If the material is loaded within the elastic limit, the stress induced in the material is directly proportional to the strain. I will repeat once again. State Hooke's law is a very popular question. Hooke's law states that, into quotes, when the material is loaded within the elastic limit, the stress produced is directly proportional to the strain. Or you can say the stress induced is directly proportional to the strain produced. Okay, so stress we are denoting by sigma is proportional to strain, that is E. If I consider the axial load, sigma is proportional to E. Now we know that for removing this sign of proportionality, I will have to introduce the constant of proportionality, that is E multiplied by small e. And what is this constant of proportionality? This constant of proportionality is known as Young's modulus or modulus of elasticity. So here you can very easily see that sigma is equal to capital E into E. Therefore, capital E, what is capital E? Modulus of elasticity is equal to stress upon strain. In this case, I will say, in this case, modulus of elasticity is direct stress upon direct strain. Okay. Now let us see what are the units of modulus of elasticity. Now, like the numbers, you can go for operations like division for units. What is the unit of sigma? Newton per mm square, MPa, GPa. What is the unit of E? E has no unit. Therefore, what is the unit of modulus of elasticity? Unit of modulus of elasticity is Newton per mm square, or you can say Pascal, or you can say megapascal, or you can say gigapascal, etc. These are the units of modulus of elasticity. Okay. Now, this Hooke's law is stress is directly proportional to strain. Now here I have taken into account the direct stress. Now, if we consider the tangential load acting, in the first video we saw different types of loads. If the load is acting like this, if I say this is the load P, this is known as shear load, and we know that due to this load the deformation will be in the form of angular deformation, or deformation will be angular. Okay, this rectangular block is fixed at the base. Now this angular deformation is say phi. Now P is the tangential load. So that tangential load upon that particular area, if I say this is the block, the load is acting like this. So what is the area resisting that tangential load is this area. Okay. So that will give you shear stress. Shear stress. Which is denoted by letter tau is equal to tangential load upon resisting area. Here I will not say cross sectional area, tangential load upon resisting area. Okay. So what will be? Tau will be P divided by area, whatever will be the area of top. Okay. So that is shear stress, and the shear strain will be shear strain. What is shear strain here? The deformation is angular, so shear strain will be phi. So now if I want to state Hooke's law in this case, I can say that shear stress is directly proportional to shear strain. Now to remove this sign of proportionality, I will place a constant, and this constant of proportionality is known as modulus of rigidity or shear modulus. So this modulus of rigidity or shear modulus, it may be represented, some books represented by C, some books represented by G, some books represented by N. We will be representing it by G. What is G? Modulus of rigidity. What is E? Modulus of elasticity. So what will be G? G will be equal to shear stress upon shear strain, will be modulus of rigidity. Okay, so mind well, what was E? In this video we saw what is E. E is modulus of elasticity and what was G or C or N? It is modulus of rigidity or rigid modulus or shear modulus. Okay, so in this particular video we saw very important properties, that is ductility, elasticity, plasticity, Ductility is very important. We saw number of metals which are ductile. Then we saw elastic limit. Then we have stated Hooke's law, and we have expressed Hooke's law for shear stress and shear strain also. So modulus of elasticity is defined as within the elastic limit, the ratio of direct stress to the linear strain is known as modulus of elasticity. The modulus of rigidity or shear modulus, C or G or N, is defined as the ratio of shear stress to the shear strain. What is the unit of modulus of elasticity? Same will be unit of modulus of rigidity also, that is Newton per mm square, Pascal, megapascal. Here also it will be same. So in the next video we will find out the expression for deformation using this Hooke's law. Thank you.